Following formulas will be provided for you on the test. You do not need to memorize these formulas, but you do need to know how to use them in the appropriate scenario. So as we take a look at problem number 6, the population P in a town in Iowa can be modeled by this function, where T is the number of years since 2005. First things first, does this model represent growth or decay? Well, what we're going to do is we're going to look at this part of the formula. Notice that 0.94 is less than 1, which means that this is going to be decay. And the thing is, it's less than 1, and what we want to know is, what is the decay rate now? And what we're going to do, what I did when we did our notes, is I said, well, let's take 100% minus 94%, 94% coming from the 0.94, which is 6%. The population in 2005 is 35,650. That first amount there. And then finally, it's what is the predicted population in 2016? Well, what we need to do first of all is we need to figure out, well, what is our time? To figure out our time, what we're going to do is we're going to take 2016 minus 2005, and when we subtract, we get 11. That's going to be our time. So we put that back into the formula, and it's going to be 35,650 times 0.94 to be 11. 35,650 times 0.94, gotta hit the right button, 0.94 to the 11. Gives us this number. Checking our directions, what we see on here is we want to round to the nearest whole number, because we are dealing with population, we're dealing with people. And what I've told you before is I would take 18,049 or 18,050. It's a matter of how you interpret it. Problem number 7. The value V of a rare coin on any number of years after it was purchased can be modeled by the function V of t equals 725 times 1.13 t. Well, does this model represent growth or decay? When we look at this, we're looking at this number. And as we can see, if I move this over a little bit, 1.13 is greater than 1. And that means that we're dealing with growth. And to figure out what the growth rate is on part B, we take 113% minus 100%, and we end up with 13%. The initial value of the coin is the first value in our formula, which is the 725. And we have to write 725. And then finally it says, what is the estimated value of the coin 12 years after purchase? Well, the formula is given to us. 725 times 1.13. We're going to put the 12 in for the t. And we're going to type that into our calculator. 725 times 1.13 to the 12. Get this number. And let's see what our directions say in terms of rounding. It says round to the nearest cent. So when we round to the nearest cent here, we're going to get 3142. We're going to look at the 9 to determine what to do to that 2. It's going to be 0.53. On July 6, 2016, Pokemon Go was launched in North America, New Zealand, and Australia, and within days it became phenomenally popular and demonstrated an astounding potential for growth. Pokemon Go has broken all previous records of popularity of any mobile game or app on both Apple's App Store and Google Play Market. Since the app's release, the number of new Pokestops has increased 25% each day. Assuming there were 250,000 Pokestops when the app launched on July 6th, how many Pokestops were there on July 20th? Show the setup of the model that leads to your answer, round to the nearest whole number. Well, the first thing that we have to do is we have to figure out which formula to use, and consequently, we need to pick out, like, what is the key word in this? And really, the key word in here is increased. And when we see increased, that means that we need to use this formula right here, which is the increased formula. And then it says, well, what will you use for the value of t? Well, what we have to do is, let's see, I need to go back and look at here. We've got the app launched on July 6th, and now we're looking at July 20th. So 20 minus 6 is 14. That's going to be our time. So it's using the information provided, fill in the model, and then solve for the number of Pokestops on July 20th. Well, our original amount, our A sub 0, as I look back in the problem, is 250,000 Pokestops. We know our time is 14, but what's our percentage? And it says that we increase 25% each day. So here's 25%. Remember, we need to move our decimal point 1, 2 spaces to the left. And we get 0.25. Again, we already know that our time is 14. And it's nice now that once we write this equation, we can simply type it into our calculator. Because it's going to be 250,000 times 1 plus 0.25 to the 14. $250,000 times 1 plus 0.25 to the 14 gives us this number. Remember what our directions say in terms of rounding. It says round to the nearest whole number. So 5, 6, 8, 4, 3, 4, 2 is what I wrote there because I was looking at the 8. We're looking at stops. So I rounded up 1, but I guess I would take, now that I look at it a little bit more, the 5, 6, 8, 4, 3, 4, 1. The Pokemon Go app downloads peaked within the first 6 days of release. There were 5.7 million new downloads on July 12th, the last of the 6 days within the peak period, and then the number of new downloads per day started to decline at a rate of 9% each day. To the nearest whole number, how many new downloads per day were there on July 21st? Show the setup of the model that leads to your answer. And first of all, we have to pick which model we're going to use in the first place. And that means that when we go back in the problem, we look for the key word in here. And the key word to me is decline. So decline means that we're going to be using this formula right here. And now what we want to figure out is, well, what are we going to use for the value of t? Well, we're looking from July 12 to July 21. So we're going to take 21 minus 12, and when we subtract those, we find out the value of t is going to be 9. Some other information that we know on this particular problem is that we're starting off with 5.7 million, and I'm going to leave it as 5.7 million new downloads. And then it says that we start to decline at a rate of 9% per day. Well, that's our P, which is 9% But again, let me remind you that we need to move the decimal point because we need to turn this into a decimal. It's a percent right now. So we're going to move it 2 spaces to the left and we get 0.09. And again, we already know that our time is 9. And the nice part on this particular problem as well is once we get this filled into the formula, 5.7 times 1 minus 0.09 to the 9 means that all we need to do to finish this problem is we need to type it into our calculator. So 5.7 times 1 minus 0.09 to the 9 gives us this value here. And as I look at the directions here in terms of show the set up models to the nearest whole number is what the problem says. And we're looking at the downloads here. So for me, when I read this, I say 2.4 million downloads because it says to the nearest whole number, so actually I need to go even a little bit more, but 2.439199861 million is what I get, and actually 2.4 million is really to the whole number. That's 2,400,000.